Section 15C, question number 3, page 369. The question asks us to find the gradient of the tangent to the following functions. So the first function is this, y equals x to the power 4, quantity 1 minus 2x all squared, and we're going to evaluate that derivative, or the gradient function at x equals negative 1, to find the gradient of that tangent to this function. So first of all, we need to find the gradient function, and we'll do that by differentiating, and we will use the product rule, and then probably have to use the chain rule there as well, considering we take a look at that second function. So we take the derivative of the first, so I bring the exponent down in front and subtract 1 from the exponent to give me 4x cubed, multiply by the second function, which stays the same. Then I will add the first function, and I will multiply that by the derivative of the second. Here I'll use the chain rule, so I bring the 2 down in front, and I leave the inside part, subtract 1 from the exponent to leave me 1 up top, and I'll go inside here and take the derivative of that, which gives me negative 2. Now I'll just tidy up a little bit. There's not really a ton that I really want to do here, because if I'm just evaluating, I may as well just evaluate it as it is. So let me see, I'll just do 4x cubed, quantity 1 minus 2x squared, and then I'll bring this stuff to the front, so I get negative 4x to the power 4, quantity 1 minus 2x. So I probably could do a little bit more simplification. Do I really want to? Not this time. So what I'm going to do is I'm going to take the derivative, I'll evaluate that at x equals negative 1, and I will substitute that negative 1 in for the x, and I will just complete this, and then I'll just start doing some simplification here. So this gives me negative 4, so negative 1 cubed is negative, multiplied by 4. Then inside here I've got negative 2 times negative 1, which is positive 2, so I get 1 plus 2 inside, still to the exponent 2. Negative 1 to the exponent 4 gives me positive 1, times negative 4 gives me negative 4, and then in here I'll have 1 plus 2. And I'll just simplify a little bit more. Negative 4, 1 plus 2 is 3, 3 squared is 9, and then negative 4 times 3. And then I'll just work this out, so negative 4 times 9 is negative 36, minus 12 gives me negative 48. So the gradient of this function, evaluated at x equals negative 1, is negative 48. In question B, we've got y equals root x, quantity x squared minus x plus 1 all squared, evaluated at x equals 4. That's of course after we find the gradient function of this function. So I'll change this into exponent form, so I'll change the root x to x to the 1/2, and then I'll leave the rest of this as it is. Now I'll find the derivative. So again, we'll do the product rule, so I'll take this, I bring the 1/2 down in front, subtract 1 from the exponent to leave me negative 1/2, leave the second function as it is, and then I will add the first function, just leave that, and then I will do the chain rule for the second part, so I will bring the 2 down in front, subtract 1 from the exponent, leave the middle part as it is, the exponent becomes 1, and then I will find the derivative of the inside, which gives me 2x minus 1. Now I've had a little change of heart in terms of simplifying, so I'm going to simplify this one by factoring a little bit, just to make sure that I can maybe save a little bit of room with all this substitution that I'm going to be doing. So I'm going to factor out a 1/2 x to the negative 1/2, x squared minus x plus 1 from both of these terms. And so that will leave me, this becomes just 1. Don't really have to write that. we've got x squared minus x plus 1 all squared divided by this, which just leaves me with x squared minus x plus 1. And when I divide x to the 1/2 by 1/2 x to the negative 1/2, I'm left with 2x. Now I'm going to take this 2 and bring it out in front and multiply with that 2. So that gives me 4 now. I've factored out this x squared minus x plus 1, so that one's now gone because I factored that out, and I'm left now with 2x minus 1. Again, I could simplify and like expand this in, simplify more, but yeah, why not? I keep changing my mind because I think, well, why simplify more? But it actually may be a little bit more beneficial when I do the substitution. So I'll get this, so I'll get 4x times 2, or yeah, 4x times 2x gives me 8x squared, and then negative 4x. And I'll simplify a little bit more. So a lot of this is just algebra, just simplifying, a little bit of a trip down memory lane to years gone by where we just simplify a lot. There we go. Okay, now that we've got that, now we'll do the substitution. So the gradient is equal to the gradient function evaluated at x equals 4. That equals 1/2, 4 to the negative 1/2. Quantity, 4 squared. Substituting the 4 for the x. And then I'll have 9 times 4 squared minus 5 times 4 plus 1. Now we'll do a little bit of mental math here, hopefully. So we got a 1/2, and so the 1/2 is obviously the square root, and that answer is going to be in the denominator, so the square root of 4 is 2, and that we get the reciprocal with the negative exponent, so that leaves me with 1/2. And then 4 squared is 16, minus 4 plus 1 is minus 3, and then over here I've got 9 times 16. Do I know that? Let's see, that would be 160 minus 16, which would be 144. Minus 20 plus 1. Hope I did that quickly and correctly in my head. A half times a half gives me a quarter, times 13. Then I'm left with 19 here, 145, or 145 minus 20 gives me 125. So if I know my 13 times tables well enough, 13 times 125 is going to give me 1625 divided by 4. And that is going to leave me with a gradient of 406 1/4. So the gradient of y equals root x, quantity x squared minus x plus 1 all squared, evaluated at x equals 4, is 406 1/4. Part C, the function is y equals x root 1 minus 2x. I'll change this format to quantity 1 minus 2x to the 1/2, and then differentiate. So I take the derivative of the first, which is 1, multiplied by the second without changing it, plus the first multiplied by the derivative of the second. So I bring the 1/2 down in front, I'll leave the middle stuff, subtract 1 from 1/2 to give me negative 1/2. Then I go inside here and take the derivative, and that gives me negative 2. I'm not going to simplify a whole lot, but I'll just kind of bring a couple things together. So I'll leave this as 1 minus 2x to the 1/2. Then I'll bring this negative 2 and the 1/2 and the x all together to leave me with negative x, quantity 1 minus 2x to the negative 1/2. And now, to find the gradient, I evaluate the gradient function at x equals negative 4. And then I'll just substitute negative 4 in. So I get 1 minus 2 times negative 4 all to the 1/2 minus negative 4 quantity 1 minus 2 times negative 4 to the negative 1/2. And then I'll just simplify all of this if possible. So inside the bracket I've got 1 minus 2 times negative 4, which is positive 8, so 1 plus 8 is 9, all to the 1/2. And I'll just do inside the brackets here first. I'll leave this negative times the negative 4 to be positive 4, multiplied by, and then again 1, negative 2 times negative 4, which is positive 8. 1 plus 8 is 9, to the negative 1/2. The square root of 9 is 3, plus 4 times the square root of 9 is 3, but with the negative it's the reciprocal, so it would be 1 over 3. So I've got 3 plus 4 over 3, and that leaves me with 13/3, because 3 is 3 over 1, which can be changed to 9 over 3, and you add that to 4 over 3, you get 13 over 3, which then can be written as 4 1/3. Alright, and we've got one more question to work on here for question 3, and that is, of course, part D. Y equals x cubed multiplied by 5 minus the square root of 5 minus x squared, and that derivative is going to be evaluated at x equals 1. So before I get carried away finding the derivative, I'm going to rewrite this to be x cubed quantity 5 minus x squared all to the 1/2. And then I will employ the product rule when I differentiate. So the derivative of the first is 3x squared multiplied by the second, so you get 5 minus x squared to the 1/2. And then I will add, the first function just stays as it is, and then I'll take the derivative of the second by bringing the 1/2 down in front. 5 minus x cubed, or that's a squared, sorry, it's a squared, and a half minus 1 gives me negative a half, and then I go inside here and take the derivative, gives me negative 2x. And then the gradient is the gradient function evaluated at x equals 1. So I've got 3 quantity 1 squared, quantity 5 minus 1 squared, all to the 1/2, plus 1 cubed, multiplied by a half times 5 minus 1 squared, to the negative 1/2, multiplied by negative 2 times 1. Oops. And closing all the brackets, we get that. And so now, we will just continue simplifying here. So I've got 1 squared is 1 times 3 gives me 3. Here I've got 5 minus 1 squared. Well, 5 minus 1 squared. 1 squared is just 1. 5 minus 1 is 4. It's the square root of 4. Plus, again, 1 cubed, it just gives me 1. Don't have to write that. Then I've got here 1 squared. 5 minus 1 squared would be 4. And so I've got 1/2 times 4 to the negative 1/2. Well, that we'll find the reciprocal and take the square root of that eventually. And this gets multiplied by negative 2. Hopefully everything is working out okay so far. And so then we're left with 3 times 2 plus a half times a half times negative 2. 6. A half times a half is 4. Negative 2 times a quarter. Sorry, a half times a half is a quarter. A quarter times negative 2 is negative 2 quarters, which is negative a half. So 6 minus a half gives me 11 halves, or 5 1/2.